Welcome to my autonomous robotic car. It allows you to travel from your starting point to a destination while avoiding any obstacles it finds along the way. To do this, it uses a Raspberry Pi computer and a depth camera. It also uses an inertial measurement unit to determine which direction it's moving in, along with how far each wheel turns to keep track of its current location. Lastly, it uses an A-star algorithm to determine the shortest path to a destination while navigating around obstacles. Here's a quick look at the components. So from underneath the car, there's a stabilizing wheel, two continuous rotation servos with a feedback sensor. From the top of the car, I used some Meccano to create a stand for the camera, and then on top of that stand is a pan and tilt servo. And here's the Raspberry Pi computer. It's about a credit card size, and then there's a case that it's in. Then on top of the Raspberry Pi, there's a motor driver board, which helps drive the motors, and an inertial movement sensor, which keeps track of the direction and acceleration. And we have a USB battery to help power the computer and the motors. And this is what it looks like when it's all put together. And now I'll get into the demo. Okay, so I've started up the program. Basically, this first window here is just showing the map. That's the car, that's the destination. It's taking the shortest path to get there. That's a straight line. It obviously doesn't know about the obstacles in the way yet. This little controller window is just what kind of captures the keystrokes. And then this is the depth map. So basically it's showing you from a depth perspective what the camera is seeing. And the darker colors are further away and the lighter colors are closer. So yellow is kind of the closest. If it gets into the red range, it means it's too close. So I'm just going to zoom in on the map a little bit. I'm just using pressing I on the keyboard, which lets you zoom in. All right, and so now what I'm going to do is I'm going to press A, which is going to take the vehicle into autonomous mode, and then it's going to try and get to the destination. All right, so here goes. So I'm going to press A. All right, so it's going towards the obstacles. You can kind of see that it's noticing things are in the way. So it's building obstacles. And it's calculating the shortest path to where that red dot is. It still sees as an obstacle at the box there, so it's going to try and get around it. And then basically it's coming in, and then it's going to try and drive right on top of that dot and stop. And so there you have it. So basically it went from the starting spot, which is that little white dot, and then finished at the red dot. And so you can see on the screen here how it's kind of mapped out the different obstacles it ran into. And then these are little breadcrumbs that are just showing where it went and what direction it's facing, and then that's where the vehicle is. So what I'm going to do next is I'm going to set the destination back to where the start was. So I'm going to press D, and then it's asking me to enter in a destination. The previous destination was 700 millimeters or 70 centimeters. Straight ahead. So I'm just going to put it back to 0 for my X and then 0 for my Y. And as soon as I hit enter, the autonomous mode is going to kick in, and then it's going to try and drive back. So let's do that. Okay, so you can kind of see it's trying to get there. Let's see how it goes. It sees that this box is in the way. It has two options. You can try and go around that box, as long as it doesn't hit any other obstacles. Yeah, and it's kind of going to make its way around. It might make its way around, we'll see. If not, we'll come back the other way. It probably had enough space just to get in around those boxes, but we'll see what it decides to do. That looks like it's going the other way around. And again, on the screen, you can kind of see the whole optical map that it's creating. And now the white box at the site. There's no obstacles in the way. And then it stops on that dot. And there you go. I wrote the program in Python, and the way it figures out if there's an obstacle is it uses the depth camera and does a line of sight past the end of the front of the car and then towards the floor. And there's about 2 centimeters between that distance. And it looks to see if there's more than 50 pixels um, showing up within that space range. And that means that, there's something in the way of the car. Right? And that works well because even with all the motion blur and the car moving, it takes the last 10 frames of information to see if there's anything in that area. And then if there is, it sort of adds it as an obstacle. And then it kind of calculates the shortest path to the destination. And, I'm just using basic triangulation there, but I'm also using an A-star algorithm, which basically looks at every single obstacle, which is a polygon, and plus the start and the destination, and it draws a line from the start to kind of a line of sight to every corner of every polygon that it can without something being in its way. And then between every obstacle, it does the same thing. It draws a line from one corner to another, and then it just kind of goes around and adds up all those lengths to see which length has the shortest path. And that's how it decides how it's going to take the shortest path to the destination. Well, I hope you enjoyed my demo, and thanks for watching.